to virtualization itself. What is virtualization? Let's look at some of the ways virtualization is defined in the industry. So basically, as I said, the term virtualization has been around for a very long time. Actually, early 60s, mainframes really virtualized the environment to get the maximum out of the mainframe resources, right? So this is really not a new technology. I mean, it is new in the distributed industry, but on the mainframe industry, it's been around. So some of the, I even picked up Wikipedia, right? I mean, I go to Wikipedia all the time. I mean, even though my wife, who's a teacher, she really hates going to Wikipedia. She says, you don't know who's writing in there. There's really nobody who reviews it. I mean, so you can't really be going. But I like Wikipedia. I go there to read, especially for definitions of terms. So Wikipedia really defines it as, it's an abstraction of computer resources, right? Basically, virtualization gives you a layer of abstraction that insulates you from the actual physical resources. So you as an application or an application writer don't need to really worry about, how do I really access the actual physical resource? So the abstraction layer gives you a standard interface that you really develop to, and then virtualization layer really takes care of taking that standard interface and translating it to the physical resources interface, right? So that is really how Wikipedia defines virtualization. And the EMA, Enterprise Management Associates really says it's a technique of abstracting or hiding physical characteristics from of computing resources from the way other systems and applications really interact. I mean, it's kind of the same thing as we just, as I just said. So again, I mean, it's a logical representation of resources. It allows one physical server to be partitioned into multiple servers, which give you multiple environments to really run your applications in. It reduces the number of servers in in your data center. It also enables you to really consolidate multiple resources and make it appear as a single resource, right? So it's really taking one and making it appear as many, and it also does the other way too, right? So the intent of the whole thing is to really achieve a simpler, scalable, cost-efficient IT infrastructure. So pictorially, right? I mean, its words are fine, but it's nice to really see some pictures and say, okay. Yeah. So on the top left, right? I mean, you have one physical resource. Top right. Top right, you have one physical resource which is really being partitioned into multiple logical resources, and each resource is really, is completely independent of the others, right? So that is really, that's the logical partitioning of systems, virtual machines. So and why do you do that? I mean, to increase your physical resource utilization, right? Then, top right is aggregation. Aggregation is really the other way, right? I mean, you take multiple physical resources, aggregate them, and make it look like multiple logical resources or single, one logical resource. So that, you do it in, more on the disk virtualization, DASD virtualization, or storage virtualization, where you really have multiple storage units from different vendors, but you really provide a virtual disk to the application and the operating system level, and the actual mapping of the virtual disk to the physical disk really happens at the virtualization layer, right? And the bottom right is the actual emulation layer. Emulation layer is really, you don't really see a lot, but when I started with IBM, we used to really have emulators quite a bit. because I started with, in processor development. So new instructions, I was in microcode group. So we used to really develop new instruction. So we would really write an emulator for that new instruction. Before the machine was really developed that could execute that instruction, we would really write an emulator that ran on a different machine. So emulation really is taking one resource and making it look like another resource, right? So that is also a virtualization, type of virtualization. Right? So you have architecture, examples are, I just talked about the architectural emulators. That was very common. We had Intel emulators on, actually even on the mid-size systems. It was the other way too. On the Intel systems, we used to really have mainframe emulators and also Unix emulators, the power system emulators we used to really run on. Right? Then, other types of emulators are, like VTL, which is a virtual tape library. For performance reasons, you really take a disk unit, which is really fast, and then make it look like a streaming tape, right? So that's another type of virtual emulation. So that also is a virtualization technique, right? And the last one is insulation. Insulation is really, it's really an advantage of virtualization, meaning because it is really virtualized, you really have the flexibility to really make changes at one level without impacting the other level, right? So you can really, the physical resources, you can bring in physical resources, you can move physical resources, you can make changes at the physical resource, but the application that is really using it is really not impacted by it, right? So. Yeah.
So virtualization, the concept, how it's being implemented on a very high level as a software tool, that is, how do you define that virtualization? Is that a hardware that you have to compare with IBM, or is it an operating system, or is that a tool which can manage all of this conceptual of either the resource sharing or aggregation or emulation or
Yeah, there are different ways, of implementing virtualization. Actually, I'm going to go into that in detail. Just to give you a quick answer, there's a layer of, it's all done in software. Whether you call it software or firmware or microcode, it is code that somebody wrote, right? So that there is a layer of software that really resides on the system, either directly on the bare metal or on top of the operating system to really give you that abstraction layer. So
that creates a big, if there is a failover, if you have a RAID, to have multiple hard drive fails, at least we have a backup on the RAID, and if the CPUs fail, then if something else is running, if the virtualization on the tool, if that fails.
Yes, if the hypervisor really has a problem, yes, things can really go bad for virtualization. Virtualization. But if the actual, if one of the resources that is being virtualized fails, if the virtualization layer has the smarts to really reassign another resource to do the same thing, yes, it can really do that. Yeah. Some do, some don't, right? But if there is a problem in the virtualization layer itself, all bets are off. You're right.
Especially in real life, Zen goes down, Zen hypervisor goes down. What we do is, we run very complex architectures. We do a disaster recovery sites. So concurrently they will be writing. If your question is very valid, if hypervisor goes down, as Seshadri was telling, 25 VMs will go away.
Yeah.
Okay? It's as good as 25 machines crashing now. All these 25 could be 25 different customers. They'll come and scream and yell at us. So what we do, every time we replicate, depending upon the complexity behind the scene. If you have an SLA commitment, like what you talk, 99.99999, then I do a replica